Welcome to this little demo. The plan for today is to show you how we can call Azure Active Directory, the Azure Resource Manager API, and interact with Azure Blob Storage from within Elixir. And in order to show and demonstrate this a little bit easier, we are hosting all the prepared code for this demo in an Elixir LiveBook running in a Docker container on my WSL instance over here. So in order to run Elixir LiveBook, the main thing to do is I'm exposing port 8080 from this LiveBook container on my local WSL2 instance. So after I did this, after I executed this shell script, LiveBook is listening at this particular address. So we're navigating here in the browser, and the next thing is we pull in a LiveBook which I prepared for this one from over here. So let me just copy the link to this Azure LiveMD as well. So this is here. This is simply speaking a markdown file with embedded Elixir code, and it is in my GitHub account. So we are going to import this one. I paste the link to my LiveBook in here after I selected import, and the code on my local machine reads this stuff. So to briefly tell you, in case you haven't seen LiveBook in the past, what it means is it feels like a Jupyter notebook for Python, but for Elixir. So and assuming that the majority of the viewers might not know Elixir, just enough information so you understand what's going on. Here, for example, I have a cell where the Elixir code in it is 12 minus 5. So when I click the little evaluate button here, this is evaluated locally in the Docker container running on my machine, and the result pops up here on my screen. Because we will see this pipe operator a little bit just to help you understand what's going on here. For example, the minus thing is just a shorthand, an infix operation for the kernel.minus function, which is called with the arguments 12.5. So kernel.minus of 12,5 gives me the 7 as well. And when I now use a pipe operator, which Elixir has landed, I believe, from F#, it basically means if I run this pipe operator here, the 12 makes it as a first argument into the function call of the subsequent function. So essentially you can see like A being piped into F, B, like here, means F of A, B, which is slightly different than F#, where the argument which you pipe in becomes the last argument. But for that matter, it's still the same thing. 12 piped into kernel minus 5 gives me the 7, and in order for readability, I can write this across multiple lines. So I can say 12 piped into the kernel subtract a 5 from the previous input gives me the 5 as well. And to show you that we are actually running on the Erlang virtual machine, we can figure out we are the process number 126 on this version of the Erlang VM. One of the neat things that Elixir and LiveBook finally gives us is we can install a whole bunch of software dependencies as part of a script. So the mix install script over here allows me to pull in a bunch of dependencies. In this case, I am pulling in 5 different code snippets, so to say, all from my different GitHub repositories. So the X Microsoft Azure Utils gives me capabilities to interact with Azure Active Directory. X Microsoft Azure Storage gives me the Elixir capabilities to interact with Azure Blob Storage. And the different things inside Microsoft Azure Management give me capabilities to interact with Azure Resource Manager APIs for resources, subscriptions, and storage. When you evaluate this one for the very first time, it actually takes around 5 minutes or so to kind of download all these dependencies onto the local machine, compile everything, and get all the ducks in a row, so to say. But because I executed the script like earlier today, all this particular mix install version has been cached locally, and so it just says OK because it did so. In Elixir, I can now use these alias statements to make our code a little bit less verbose by bringing in the Azure Device Authenticator library and so on. And we also set a set of API versions. So this is the Elixir syntax to create a dictionary, a map, so to say, so in which I essentially bind, various, resource group, subscription, and storage atoms to these, API versions. Up until now, it hasn't been really interesting. Now we start to get into the Azure Active Directory interactions. So what I'm doing now is we want to authenticate to Azure Active Directory in order to talk to the Azure Management API. So this state here effectively is a setting on how I want to interact with Azure Active Directory. So I say I want to talk to Azure, to the Management API in the Azure Global environment, so to say. So and in the scope of a particular Azure Active Directory tenant which I'm using. And this state is being piped into the Device Authenticator Supervisor start link function. And as a result, this supervisor spins up a supervisor process, represented by a process ID, a management process ID. And this is my main way to interface with my Azure Active Directory kind of token authenticator. So here, the process has been started. Process number 300 on my VM is the thing which takes care of fetching tokens for me. So this process is alive. When I send the process ID into process alive, it's true. Actually, there are a whole bunch of different processes running on my Erlang virtual machine. I can also use this to look into what's the current state of this process. These are basically all Erlang and Elixir internal capabilities to inspect what's going on. This process is currently waiting for work to happen. And what we can do now is I can ask the Device Authenticator get stage function on my process ID, and it tells me I have been initialized, but nothing more. So the next thing we do is we ask our management process ID to get us a device code. The result is pattern matched into this data structure where we grab the user code by which we want to authenticate in the UC variable. And then we basically return the string use user code UC in order to do the device authentication. So once we do this, it now tells me that this here is the code for the device sign-in. So when I follow the sign-in mechanism over here, it basically Geuer at Microsoft.com. I am now signing in to my Azure subscription. Of course, there is a two-factor prompt on my mobile phone here so that I can successfully pop in. It now asks me, are you willing to sign in? Yes, I am. And at this point in time, we have been authenticated. So what I now can do is I can basically ask the process to give me the token. I pattern match it into this data structure and return the management token. So when we have a look over here, no surprises actually, we get a JSON web token. So by the way, instead of doing all this pattern matching stuff, I could also have said like use a process ID, gets a token, takes the first element from this, the second element from this tuple, and inside it give me the access token element. It basically returns the same thing. we can peek into this management token by running this little code. So we pipe the string into the Jose is basically the JSON object signature and encryption package for JSON web tokens. So we can peek into it, we can look into the fields. Here I'm formatting this using a lambda function, which creates a nice string out of it. I join all these things with caret returns, and as a result I can see what's inside this particular token. So I have been authenticated using a particular mechanism and so on. The identity provider is my Azure Active Directory and so on and so on. So if we could also use this just to kind of look at the same token in Jort.ms. So Jort.ms is Microsoft's little web page, single page application which helps you to crack up these tokens. It's the same set of information, so to say. This now is a token, just to bring the attention to it. The audience for this token is the Azure Management API. So we now can use this. We create an HTTP client. So here Tesla is the HTTP library which I'm using, and it now uses this Bearer token to sign in. So now what we can do is we use this connection which contains our token and call the subscription management subscription list API in a certain API version and get the value. And this is a list of all the subscriptions that I do have access to. And I'm then filtering these subscriptions down to pick the one where the subscription's display name is equal to ch-Geuer work. And then we select the head of the list, the first element of this list, and we just get the subscription ID. So when we run this, and what happened now under the hood, this really was a REST call against the Azure Resource Manager API. And it binds the subscription ID that I care about onto this value subscription ID. So in the next step, I can now, for example, use the Azure Resource Manager Storage Accounts API, which I just here for shorthand called Storage Management, to list all the storage accounts that I do have access to. So when I evaluate this one, it now gives me a list of various storage accounts that I can play with. And if I simply take this account list and just extract the name from it, I can see here a whole bunch of different storage accounts which are part of my subscription. So now let's play with one of these storage accounts. In order to talk to the storage account, which is a data plane, we again need a security token from Azure Active Directory, but this time it's not for the management plane but for the storage plane. So let's spin up another process for handling talking to Azure Active Directory, but now on the storage side of the house. So let's see, this has been initialized but nothing more. So again we say we want to authenticate using a storage using a device code flow. So let's select this code. Let's go to Azure to Microsoft.com device login, authenticate here. This time we don't need to do the two-factor thing because I am still signed in. And when we now validate where we are, it is already in the state refreshing. So refreshing means our process has both a valid access token but also a refresh token, and that process is constantly looking like, do we have kind of a valid token in our hand, otherwise refresh it. That's why it's saying refreshing here. So when we get the token, same thing like before, we have somewhere down there we have a bearer token. I do not print it out here in the debug statement, and when I use Jose again to jump into it, we can see this token has been created for talking to Azure Storage. So now actually let's talk to Azure Storage. Let's again remind ourselves about what are the different storage accounts we are having here. So let's, for example, take this BLT CDN storage account and put it into this little text box here. So this here is a text box where I, as a user in this LiveBook diagram, and in this LiveBook can supply user input. So here we read essentially the contents of the storage account name. Then we create a Lambda function. So this here is Elixir's way to create a Lambda function, which basically always asks the process which works with Azure Active Directory to give us the most recent token, extract it, and give it back to us. And so our storage data structure is represented by the storage account name, which you want to use the appropriate suffix, so we're talking to the right environment, and a Lambda function, which always gives us a valid access token for storage. So here you go, and you can also see AAD token provider effectively is a Lambda function. Let me just comment this stuff out because I don't want to send traffic to Fiddler locally. We ignore this thing. So now it's time to interact with Azure Storage. So we take this storage data structure, which you've seen here before, this data structure, and we pipe it into the containers.listContainers function. So when we run this particular code, we basically get an OK back together with a response structure which includes these containers, and then we iterate over the containers and we just grab the actual name of the container. So here we now do have a couple of names. So for example, we could now say create a new container, container123. Let's read this into the system, and now we can say create Control KC, there is KU, there is actually a Visual Studio Code inside this instance, and now we can create this container. So inside our BTL CDN storage account, the container 123 has been created, and we can for example also list the blobs inside this container, which are non-existent. And inside the container, inside the data drive, the data directory on my Docker container, I have a little video which I can here, for example, now upload. So I'm basically saying in the storage, use this container to upload a file. And when we run this one, we can now see that the file has been uploaded to this particular address. And when we now list the amount of blobs in this container, we can see, okay, these go to 11.mp4, there's actually the file. And to just show you where the file is, this is a private container currently. When I go to my Azure portal, into our storage account, towards the containers, we have our container 123, and in this there's effectively our container, and that's all for our demo today. Have a great day, enjoy the rest of the week.